Hello everyone, welcome to Mudgal Education. I hope everybody is doing very well guys, and this is going to be a second session of our signal system in which we are discussing the energy and the power signal. So if you haven't watched my previous session, I will advise you to watch my previous session on this particular, that was a part 1. So either you can watch this, either you can find the link on the I button on this video, or I will also pin that particular link in the description, so you can watch my previous video and then we can continue this particular video. So let's discuss what we have seen in the last class. So we are discussing actually the classification of a signals, and one of the important classification we have is the energy and a power signal. So before discussing this classification, you need to understand how to calculate energy and power of a different signals. So in the first part, we already discussed the way to calculate the energy of a continuous time and a discrete time signal. In this class, we are going to discuss how to calculate the power of a particular signal, and then we will see which signals are energy signals, which are power, and which are neither energy nor power. Okay. So before starting the session, let me introduce myself. My name is Ishaan Mudgal. I have a 7+ year of teaching experience. I'm a gold medalist from NIT Allahabad, 8 times get qualified, and these are my area of expertise. Now before going further, there is a very important information for all of you guys, that my app has been launched and the name of my app is Mudgal Education by Ishaan Mudgal. You can just watch this particular video to get to understand this particular app. Wait a sec. Just give me 1 sec here. Okay, on a Play Store you can find my app. There is some particular problem in discussing this. Here you can see how to download the app from a Play Store. You just need to type the Mudgal Education. Once you type it, you can see the particular app on the Play Store. Just install this particular app, and then after installation you can go to a app, and right now the app is in a beta section. As you can see on this app right now, 3 courses are live on which the classes are going to start from 29th April. Also you can connect with us on my Telegram channel. The link is given in this particular app, also in description of this video, and the YouTube on this what you are watching this particular lecture. So these 3 courses are live right now, which are going to start from 29th April. So don't forget to attend this class. On this particular app you can get a direct access to talk to me, to chat with me. Also there are multiple options you can find out in this particular app. Okay, so I'm hoping everybody to see you on the live class on 29th April. Now let's start our discussion. Enough with the promotions, right? Let's start our discussion. So what is the power? So basically from a childhood we have learning one thing, that power is basically the energy divided by time, right? In 9th 10th you have already learned this particular thing, that power is energy divided by time. Absolutely correct. Now in a signal terms, this particular statement is also true, and since this particular statement is true, just we need to write down a different kind of power for a different kind of signals. Okay, so for a continuous time signal there are 2 possibilities. The first possibility is that we have non-periodic signal. The first possibility we have is a non-periodic signal. Now what happened in a non-periodic signal? The power is equal to limit t tends to infinity 1 by 2t minus t to t x t whole square dt. Now if you have watched my previous video, we have already discussed this was the formula of power. This was the formula of power that we have already, this was the formula of energy that we have already discussed in our last video. Now what we have done, we have just divided by a time and taken integration. Okay, simple concept. This formula you need to learn. For a periodic signal, what is the formula that you need to remember? For a periodic signal, now for a periodic signal that we have discussed in a last class also, the energy is actually infinite. Now you cannot take a total energy in case of a periodic signal. You have to take energy of a one time period. So I'm going to take energy in a single time period. The formula is integration of a square of a signal in a one time period divided by 1 by t. Now one more point, this is actually the average power we are calculating. It is not an instantaneous power. Remember this point also. So these are the average power that we are calculating. So these two formulas are important, again based on a non-periodic and periodic signal, whereas in case of energy I told you, you just need to remember one formula, but here you have to remember two formulas. Now similarly for a discrete time signal, if you have a non-periodic signal, again the formula is simple. The power is equal to limit n tends to infinity 1 upon 2n plus 1 sigma. Remember, in case of discrete, the particular integration in a continuous change into a summation form, discrete x n whole square, right? Now what happened in case of a periodic signal? So in case of a periodic signal, the power is equal to 1 upon n naught sigma n naught x n whole square. Again, what is n naught? N naught is a time period here. So here also we are calculating the energy in one time period and divide by the complete time period. We are calculating the energy in one time period and divided by a complete time period. So same formula, just like in a continuous signal, just the point is the integration will change into a summation form. Okay, understand this form. Now let's discuss the signals of a few. Let's discuss the power of a few signal. Okay, let me draw a different signals and we will find out the power of those signal. Okay, for example, question 1. I have a signal xt is equal to a times of ut. We need to find out the power of this signal. Now earlier in the last class we already find out the energy of this signal. The energy that we calculated was infinite in this particular case. Now what is the power in this case? So again you can see this is a non-periodic signal. Here you can say this is a non-periodic signal. Okay, now here what is the formula I need to use? Limit t tends to infinity 1 upon 2t minus t to t xt whole square dt. This formula I need to use here. Now if I draw the xt here, the xt is like this. Okay, so I have to take one particular limit where there is a discontinuity. Remember, when we are doing the integration here, you have to take a limit in which the discontinuity occur. So I can take this particular limit from here to here. Let's suppose this is t by 2, this is minus t by 2, or you can say the minus t to t, that is also correct, or you can say the minus t to t, that is also correct. No worries about this. What's the point I'm discussing here? Let me show you. Just let me show you here. You can also show minus t to t, that is also correct, or minus t by 2, that is also correct. Okay, because this is a step signal, the particular value is not going to change, so that's why you can take minus t by 2 or plus t by 2. That's totally up to you. So here limit t tends to infinity 1 by 2t minus t to t. So this is AUT. So AUT means we have a square ut whole square dt. Now what is a step signal? Now in a step signal, the magnitude is equal to 1 from 0 to infinity. So the limit will change from 0 to t. And it will be a square dt, of course, because of the step signal present here. Now if I do the integration, it comes out to be a square divide by 2t multiply I can say t minus 0, and it comes out to be a square by 2. There is no need to put the t and t will cancel out, so there is no need for a limit here. So it comes out to be a square by 2. Simple. So for a step signal, the power is a square by 2, whereas for the step signal, the energy was infinite. Okay, we are going to summarize these things. Okay, though just you need to remember these particular points. Now let's take another question. Let's take I can get this one. Xt is equal to e raised to power jt. Now again remember, for this particular question we have already solved the energy. In this particular case, in this particular signal, the energy was infinite. Now let's talk about power here. So again, power, I will say power. Now here you can see sine gt, I can write down it is as a cos t plus j sin t. I can write down it as a cos t plus j sin t. Or why, what's the main point I need to discuss here, that this is a periodic signal. The main point is that this particular is a periodic signal. So if you have a periodic signal here, then you can use the periodic signal formula, right? So what is the period here? What is the period here? Okay, for example, e raised to power jt, I can write down cos t plus j sin t. Absolutely correct. Any problem here? So you can say the omega, angular frequency, is equal to 1. So 2 pi by t is equal to 1. So we can say time period is 2 pi. Simple. So here that time period is actually 2 pi. Now the formula in case of a periodic signal, the formula is 1 by t integration of minus t by t x t whole square dt. Simple formula. See very carefully. We have already write down the formula here. We need to do the integration one time period when you have a periodic signal. So the time period here is actually 2 pi. So I can say from minus 2 pi to 2 pi. Okay, xt whole square. Now the point here is, we need to do that in one time period. Nah, my fault. We have to do the integration in a one time period. So what we can do here, we can do the integration from minus pi to pi. We can do the integration from minus pi to pi, because we have clearly discussed this particular point that we need to integrate in a one time period. So I will say minus pi to pi. Okay, now signal xt whole square means e raised to power jt magnitude whole square dt. Now in the last class we have already discussed the magnitude here. The magnitude of e raised to power jt is actually 1. So it is 1 square dt. Now if you integrate here, you will get 1 upon 2 pi. I will say it becomes 1 upon 2 pi. Now 1 whole square. So obviously the integration comes out to be t from minus pi to pi. So it comes out to be 1. So for this particular signal, the power that we have calculated is actually equal to 1. Simple. Any doubt here? Any doubt here? If you have any doubt, you can ask. If you have any doubt, you can ask. Okay, now let's do the next one. Let's do the next one. Now part C. So we have a signal xt. We have a signal xt. I will say minus 1 1 0 3 and like this. We need to find out the particular power here. Now to solve this question, first of all I can find out the energy. Okay, the simpler way to solve this question is to find out the energy of a signal x. Now in a discrete form, what is the energy formula? Simple. N equal to minus infinity to infinity x n whole square. This is n, sorry, this is not a xn. xn whole square. So we will say n equal to minus 1 to 2 because it is minus 1, n equal to 0, n equal to 1, n equal to 2, x n whole square, right? Now what is minus? Okay, minus 1, the value is minus 1. For 0 the value is 1. For n equal to 1 the value is 0. For n equal to 2 the value is 3. So I will say 1 plus 1 2. I will say 1 plus 1 1 plus 1 2 plus 9 11. Okay, we have a 11 units. Now what is the power? The simple formula of power is equal to limit n tends to infinity 1 upon 2n plus 1 multiply by energy, multiply by the energy. Simple in case of a non-periodic signal. So we have limit n tends to infinity 11 divided by 2n plus 1. Now if you put infinity here, it comes out to be 0. If you put infinity here, it comes out to be 0. Okay, so energy of this particular signal is 0, and you can see that this is a non-periodic finite duration signal. The particular power for this signal is equal to 0. Okay, now let me summarize these results. Let me summarize all of these points, because in the final point you need to understand to identify how to identify the energy and a power signal. So we need to summarize all of these points. So let me talk about different kind of signals. So we have signals. If you see very carefully, we have two type of signal. One is non-periodic. One type is non-periodic, another type is periodic. Another type is periodic. Okay, in case of non-periodic, again I have a two particular classification. One is finite duration signal, finite duration signal, and another one is infinite duration signal, infinite duration signal. Right now, what are the example? In periodic signal, again we have two classification. We have a finite duration and an infinite duration. In a periodic, we have a two classification again. I will say we have e raised to power j. There is no need to do the two classification in case of a periodic. Let me discuss first this point. Okay, so first of all, we have already discussed these point in an earlier class, in the last class, that because of a classification, there is so many things that you need to understand first, right? Remember one point, that we have find out the rectangular signal energy, we have find out the energy of a triangular signal. Now when you find out energy, always remember, if you are finding out energy of a periodic signal, listen this point very carefully. If you are finding out energy of a periodic signal, then energy is going to be infinite. That's a very important point. The energy will be finite, the energy will be finite. That next point is very important. The energy will be finite if at t tends to infinity, the magnitude is becoming 0. If magnitude is not becoming 0, then energy is not finite, then the energy is not finite. Okay, so this is a very important point to note down. Okay, now let's further discuss this particular point. So we have a non-periodic signal where we have a finite duration signal. Example here is a rectangular signal. Example here is a rectangular signal, or you can say the triangle signal, or you can say a triangle signal. Then we have an infinite duration signal. Now infinite duration signal again will be divided into two parts. In an infinite duration signal, we have those signal where the magnitude tends to infinity. Those signal where at t tends to infinite, the signal is 0, and those signal where at t tends to infinite, the signal is not equal to 0. Now what is the example of these kind of a signal? The example of these kind of a signals are, let's suppose this one is an exponential signal. Exponential signal. An example of this signal is ramp signal. Example of this signal is a ramp signal. Okay, now in case of a periodic, again we can say only periodic, no need to classify the periodic again, no need to classify a periodic again. Or also you can classify periodic in two ways. You can classify the periodic in two ways. Okay, although that's not very important, but let me tell you. Periodic first form, in which you have a finite energy in one cycle. Obviously, if you want to talk about the complete periodic signal, the energy will be infinite. And next, in which you have a infinite energy, in one cycle, infinite energy in one cycle. For example here is sinusoidal signal. Example here is a sinusoidal signal, and the example here is a tangent signal or a tan signal. Okay, now let's talk about the finite duration signal. So when you talk about the rectangular signal or a triangle signal, what happened here, we already discussed the energy in the last case. The energy here is actually finite. The energy here is actually finite, but the power here will be infinite. Why? The energy is finite. So if energy is finite, energy divided by time period, and you are then going to take the t tends to infinity. Obviously, now let's discuss this point. Limit t tends to infinity, energy by time period. This is the formula of power. So if this is finite, then t tends to infinity, power comes out to be 0. I kept it, let me see one point. I have put finite. Power comes out to be 0. Sorry, my fault. I put the infinite here. My fault. The power comes out to be 0. That's why derivation is important. That's why a derivation is important. So power comes out to be 0. Now, in case of an infinite duration, xt tends to infinity, again the energy is finite. And again the power here comes out to be 0. Now in this case, the energy is infinite. We already seen this case in the last class, and in this case also the power is infinite. Okay, Now in this case where finite energy in one cycle, here we have already discussed the energy is finite. Obviously the case is finite energy, and the power here. So let me talk about one point. If we talk about the complete energy, because we have already discussed this is the energy in one cycle, it's going to be finite, the classification is already there. Now if you calculate the total energy here, if you calculate the total energy here, if you calculate the total energy, that would be infinite, but if you calculate the power, that will be finite. For example, the last signal that we have seen, for example, e raised to power jt, right? Now here when you have an infinite energy in one cycle, obviously you have a total energy which is going to be infinite, and power here is also going to be infinite. Power here is also going to be infinite. So these are the kind of signals you need to understand, you need to remember here. Now what are the energy signals? So those signals, these are the classification. In case of an energy signal, the energy should be finite and power should be zero. The energy should be finite and a power should be zero. For example, this signal, the finite duration, non-periodic finite duration signal, the energy is finite and power is zero. Also, this is infinite duration signal in which the magnitude of a signal tends to 0 at t tends to infinity. This is going to be a infinite duration signal. Or here also bachcho, you need to understand these two are the energy signals. These two are the energy signals. Now what are the power signals? If we have an energy signal here, then it means we also have a power signal. Let me write down here. These two are actually the energy signals. Now what is power signal? In a power signal, the energy is infinite and the average power is actually finite. Energy is infinite and the average power is actually finite. So if energy is infinite and average power is finite, so which are the cases you can see here? In a periodic in which finite energy in one cycle, you can note here that energy is infinite but the power is finite. Energy is infinite but the power is finite. So this is going to be a power signal. Yes or no? Understand this point? Understand this point? These points are very, very important to understand. Okay, I hope you understand this point. And also which are the I can say also which particular type of energy you have. For example, you have a non-periodic signal in which you have a finite. One particular signal we left here. If in case of a non-periodic signal, I have a non-periodic, let me write down the next case here. Let me write down the case here. So in a power signal, one more case we have, which is non-periodic finite amplitude case. Non-periodic finite amplitude signals. These are also the power signals. These are also the power signal. For example, we have a step signal. We have a step signal AUT. It is non-periodic, but the amplitude is finite. Also, you can say here there are two type of infinite duration signal. Okay, we have discussed at t tends to infinity xt not 0, at t tends to infinity xt not equal to 0. Now if you want to classify this, you want to classify again in this manner, you can also classify again in this manner. For example, let me increase the classification. Let me increase the classification, guys, so that everything will be on one particular page. So let me increase the classification here. So here there are two classification in which x infinity is equal to infinite, and which x infinity is finite. So x infinity is equal to infinite in this case, where x infinity is equal to infinite. For example, the ramp signal. For example, we have a ramp signal. For example, here we have a ramp signal, and for example here we have a step signal. So in case of x infinity, energy is infinite, power is also infinite. In this case, energy is infinite, but the power is actually finite. Power is actually the finite here. So since the power is finite here, so it will become the power signal. So this particular point, these particular signals and these particular signals are actually a power signal, okay. Now remaining signals are neither energy nor power. For example, ramp signal, tangent signal. Also note this particular point, that impulse signal is also neither energy nor power signal. Okay, understood this point? So in this way you can identify the energy and a power signal. Also there are some trick to identify the energy signal. If t tends to infinity, xt is 0, and t tends to minus infinity, xt is 0, then xt is an energy signal. Okay, for example, I have an xt e raised to power minus 80. Okay, now what will be the x infinity? It will be e raised to power minus infinity, it will be 0. So it means this is a energy signal, and for the energy signal, energy is finite but the power is infinite. Now let's talk about, power is 0. For example, xt e raised to power 80. What is x infinity here? E raised to power infinity, it comes out to be infinite. So here the energy is infinite, and if you calculate the power, that will also going to be infinite here. So this is actually neither energy nor power. Okay, so to identify an energy signal, simply you have to put t tends to infinity if it giving you 0, or t tends to minus infinity if it's giving you 0. It means the particular signal is an energy signal having finite energy but a 0 average power. Now trick to identify a power signal: if limit t tends to infinity, you are getting some non-zero constant, okay, or at t tends to minus infinity, you are getting a non-zero constant, then it is a power signal. For example, we take this signal xt is equal to a ut. Okay, now if you put t tends to infinity, it comes out to be a u infinity, which is actually equal to a because u infinity is 1. So here this is actually a power signal. For a power signal, the energy is infinite but the power is finite. So in this way you can identify which signals are energy signals and which signals are power signal. Very easy concept to know about. Very easy concept. Okay, any doubt here? If you have any doubt, you can ask. If you have any doubt, you can ask here, because it's a very simple virtue. This concept is very simple. Okay, wait a sec, there's one problem on my app. Wait a sec. Okay, now moving further, let me tell you guys that you can download my app. Where you can get the link to my paid courses. The courses is going to live from 29th April, which means the next Monday. So avail this opportunity and prepare with me, so that in the next GATE examination, also all the government examination that you are going to give in the next 1-2 years, you are going to excel in each and every field. Okay, and the courses and the fees of courses are also put at some minimum level, so you can also avail this opportunity. Okay, now moving further, let me discuss about power. Also for this point also you can note about this: the signals which are not following the previous two tricks are neither energy nor power signals. Now what are the important points about energy and power signal? All finite duration bounded signals are energy signals. You can read these points by yourself. I have already explained this on this particular page, in which we have discussed all about a different kind of signals. Okay, you can read it by yourself. Now before moving further, this was one topic that we have discussed in a last class about the impact of shifting scaling on energy of a signal. Now that's the same topic we need to learn for the power also. So impact of shifting and scaling on power of signals. Okay, simple concept. Let me revise you about energy. For example, I have a signal yt is equal to a times of x at plus b. So in this particular signal, we have done the amplitude scaling, time shifting and time scaling. Now what is the energy of a signal y? It is equal to a square times of energy of a signal x divided by a. It means there is no impact of time shifting, but there will be an impact of time scaling and amplitude scaling in case of a energy of a signal. Okay, now what about in case of a power of a signal? The concept is very easy. First, if you do the time shifting, in case of time shifting, for example, if power of xt, if power of xt is p, then power of x t plus minus t naught is also equal to p. It means there is no impact on the time scaling. There is no impact on a time scaling. Now let's talk about time. Sorry, my fault. There is no impact of a time shifting. Remember this point. There is no impact of a time shifting. So if power of xt is p, then what happen in case of a time scaling? Then power of xat also remains p. Again, there is no impact of the time scaling, but there was an impact of time scaling in case of a energy of a signal. It has been divided by the mod of the amount of the time scaling. Now next, if power of xt is p, then power of a times of xt, which means we are doing the amplitude scaling, it become a square p, which is exactly similar to the energy, So we can say if xt, we can say this particular point here, wait a sec, we can say this particular point here, if power of xt is p, then power of a times of x at plus b is equal to a square p. There is no impact of time shifting or a time scaling on a signal power. Simple as it is, है ना? Now similarly, the combination of a signals, again in case of energy we have already discussed the combination of a signal. Now remember, energy I already told you in my first part of a video, so watch that particular video. Description will the link will be given in the description also. So combination of signals, if you talk about the combination of signals, so what happened in the combination of signals? For example, I have a signal xt of x1t plus x2t. Now if I want to calculate the power of xt, the simple formula is limit t tends to infinity 1 by 2t minus t2t x1t x1t I will say x1t plus x2t mod whole square dt. Now remember, in the last class we discussed this particular point, how to open the mode of a square of a mode. We have already discussed how to open the square of a mode. So it will comes out to be x1t whole square plus x2t whole square plus x1t x2 conjugate t plus x2 t x1 conjugate t. Okay, we already discussed this point in the last class, dt. Now understand here, if you talk about the orthogonal signal, which means if x1t and x2t are orthogonal signals. Now what is the meaning of orthogonal signals? In which there is no overlapping between two signals. So if you have an orthogonal signal, then you can say x1t x2t conjugate integration in a one time period dt is actually equal to 0. So if you have a orthogonal signal that you are going to get in almost every question, then these two terms become 0. And you will left with power of a signal x is equal to limit t tends to infinity 1 by 2t minus t2t x1t whole square dt plus limit t tends to infinity 1 by 2t minus t2t x2t whole square dt. Now this is actually power of a signal x1 and this is power of a signal x2. So this is the complete power formula for the orthogonal signals. You just need to add power of a individual signals. Once you add the power of a individual signals, you can solve it very easily. Okay. Now let's do a few questions over the power. For example, we have this particular question. I have a signal like this. I have a rectangular signal like this. I have a rectangular signal like this. It is 0, it is t by 2, it is t, it is a, it is minus a, it is xt, it is t. So we need to find out the power of this particular case. Now here, first of all, I can see this is a periodic signal. This is the periodic signal. So the power will be, you need to find out energy in one time period and divide it by a time period, then you get the power, right? So I'm going to find out energy in one time period. So it will be 0 to t x t whole square dt. 0 se t x t whole square dt. Now if you talk about from 0 se t by 2, the magnitude is a. From t by 2 to t, the magnitude is actually minus a. But if you square these things, then it become a square. If you square this thing, it become a square. So I can directly write down 0 se t a square dt. Now after that, it comes out to be a square multiplied by t. Now what is the power? Power is energy in one time period divided by time period. So it comes out to be a square by t divided by t is equal to a square. So this is the formula of power. Now before going further, remember one point, we have discussed this. If you remember the results that we have find out in the last class, let me revise that particular result. For a rectangular signal, if I have a rectangular signal 0 say t, and this is known as a duration. For this signal, I told you, remember the formula of energy. The energy is equal to magnitude whole square multiplied by duration. Now if you talk about again a triangular signal, like this, 0 say t is, then here what was the formula of energy? A square multiplied by duration by 3. Now if you have a sawtooth waveform means like this, right angle triangle like this. Let's suppose this is a duration. So the formula is a square divided by duration divided by 6. Okay. Now this is actually energy. Now if you talk about power, what is power? Now if this signal convert into a periodic signal, for example, I have a periodic signal like this. Like this. So I already know the energy. I need to divide it by a one time period. It comes out to be a square. Why? Because in this case, the duration become one time period. The power comes out to be a square. Okay. Now let me do one point. This is the formula of this only. The formula of a square duration by 3 is actually a formula of one triangle. Okay. Now if I have a periodic signal like this, the energy of one triangle, I already know it is the a square duration by 3. Now if I divide it by duration, or in this case the time period, it comes out to be a square by 3. Similarly, if I have a periodic signal of the sawtooth waveform, that we usually find out in analog, in this case power become energy in one time period, which is this, divided by duration, which is a time period here. It comes out to be a square by 6. Okay, understand this point. Now one important note here, let me tell you one important note here, that RMS value of any signal is under root of the power. This is also the one important note here you need to understand. RMS value of any signal is actually under root of its power. So in first case the RMS is A, in second case RMS is A by root 3, and in the last case the RMS is A by root 6. So this is also one important point you need to understand here. This will help you to solve the question much easier. This will help you to solve the question much easier. Understood? Let me solve one question. Let me ask you one question here. Okay. Let's solve one question based on the previous concepts that we have discussed. So for example, I have this particular signal xt. Okay, I have a signal xt like this. Okay, I have a signal xt like this, such that this is, I will say, let's say 4. This is 4. This is minus 4. I will say this is 5. This is 10. The question is, find the power of a signal yt which is equal to 2 times of x 1 minus t divided by 4. Okay, now to solve this question, first we need to find out the power of a signal xt. So first we need to find out a power of a signal xt. Now this particular signal, if you talk about one time period, this is one time period, this is one time period. In a one time period, I can divide the particular signal like this. Or if you want to about total division, you can also find out, but I'm talking about in one time period. In a one time period, I can say this is x1t from 0 to 5, magnitude is 4, and in one time period we have a triangle signal from 5 to 10, from 5 to 10, which is actually a minus 4. Okay, understood. Now here I can find out the power of these individual signals. It's very easy to find out the power of these individual signals. Now what is the power in case of a rectangle signal? Very easy, the magnitude whole square. What is the power in case of this signal? Magnitude whole square. Or if you don't remember the power, for example, you don't remember the power, you only remember the energy, you can find out energy here also. So let's find out energy of these signals, and then we will divide by time period to find out the power. So what is the energy in this case? The energy formula is magnitude whole square multiplied by duration. Magnitude whole square multiplied by duration. I hope you understand this point. So it comes out to be 16 5 ja 80. Now what is the energy in this case? Magnitude whole square multiply by duration. Duration is 5. This is duration, but this is a right angle triangle, so divide by 6. This is a right angle triangle, so divide by 6. Okay, this formula. So a square duration by 6. So it comes out to 1650 80 by 6, or I can say 2 to 40 by 3. 40 by 3. So what is the total energy in one time period? 80 plus 40 by 3. So it comes out to be 280 by 3. Okay, but we need to find out the power. So what is power? Basically power is equal to energy divided by the time period, because we are talking about a periodic signal. So power of signal x is 280 divided by 3 multiplied by 10. It comes out to be 28 by 3. It comes out to be a 28 by 3. So I hope you understand this point. The power comes out to be 28 by 3 of a signal x. Now we have a signal y. We have a signal y such that it is equal to 2 times of x 1 minus t by 4. Now we have already discussed power does not get impacted because of the time scaling or a time shifting. Only the amplitude scaling will change the power. So what will be the power of signal y? It is 2 whole square power of a signal x, which means 4 multiplied by 28 by 3. So 4 8 32, 112 by 3 units. So simple, we have calculated the power of a signal y here. Okay, simple hai, just you need to understand the concept carefully, otherwise it's very simple. Okay, if you don't understand the concept, then I will say ki yeah, this will be a difficult task, but not anymore. If you are watching my videos, I'm pretty much sure that you got this concept very easily. Okay, so I will advise you to solve many questions on a that has been asked in a previous year in both electrical, EC and IN, so that you can understand the complete concept very much. So I'm going to end my video here. If you have any doubt, you can ask your doubt in the comment section. Also, you can join my Telegram channel to ask your doubts. Don't forget to subscribe my YouTube channel. Also, download the app to avail the paid courses at very minimum level. Okay, so bye guys, take care, see you in the next video. Bye.